All right, here we go with video 1 for chapter 13. In this video, we're going to review how to locate and plot points on a coordinate graph. And when I say coordinate graph, I mean a graph like this with the x and y axis. We're going to see that for linear equations, the solutions to that linear equations will be points on the line. So if we graph an equation, all of these points along this line are going to be solutions to that equation. And we're going to graph linear equations by plugging in different values of x and making our own table. Okay. So we already said this is an example of a coordinate graph. Notice your x-axis, your y-axis, your origin would be here in the middle. When we say ordered pairs, we're talking about those xy pairs, and we'll review how to read those and how to graph the points here. Remember, the x tells you where to go on the x-axis, so right or left. I like to think of that first number as telling me which way to move over. Right? We always start at the origin, and then how many do we go over? And then the y-coordinate tells us how many do we go up or down. So let's try a couple. Oh, let's fill in quadrants though. We know this is the first quadrant, second quadrant, third quadrant, fourth quadrant. So they have names. All right. What point is located at 2, 3? Well, over 2, start at the origin, over 2, up 3. So I get S. -4, 0 would be left 4, and then the 0 means not up or down, right? Stay right there. I see that's point R. What are the coordinates of point U? Well, it looks like left 3, down 4. So the x-axis is -3, the y-axis is -4. What are the coordinates of point T? To the right 5 and down 2. So +5 and -2. And then what point is located in quadrant 2? That would be point N. So I know that's just a really quick review, but we've got to be able to take points and plot them, or looking at the points on a graph, know what those coordinates are. Okay, we've already learned a lot about linear equations in chapter 3 earlier in the year. Okay, in a linear equation, we had examples like this. 5 plus 2x, or y equals -3x minus 7. Okay, and we talked about earlier this year how the number by itself is the starting value. That's something we already used and talked about. And we also talked about how the number with the x, so in this example 2, or in this example the -3, is the rate or the slope. Some places also call this the constant of proportionality if it is a proportional relationship. So we saw that term as well. Remember to keep all the negative signs glued to what comes after or behind them. So let's look at a couple examples. In an example like this, the number by itself is the starting value, and the number with the x is the rate. The number by itself, here's a negative glued to that 9. The number by itself is the starting value, and the number with the x is the rate. The number by itself is the starting value, and the number with the x is the rate. Number by itself, number with the x. So that's pretty much where we left off in chapter 3. We're going to build on all of that in this chapter. So, linear equation. Y equals a starting value plus or minus that rate with the x. And we talked about how these could be flip-flopped. Maybe you see y equals the rate first with the x, and then plus or minus a starting value. Both of these are fine. Those would both be linear equations. Really, we're just talking about where there's no exponents. No exponents on the variables here. And when we graph them, we should get a straight line. Okay. Solution points are all the XY pairs that work. All the XY pairs that work. So we're going to see in this section that every point on a linear graph is a solution to that equation, right? If it's a point on the graph, an XY point on the graph, then that X and that Y will work when I plug it into the equation. And every solution will be a point on the line of a linear equation. So it goes both ways. If you make a table of XY values and find an X and a Y that work, it's going to be a point on the graph. Or if you have a point on the graph, right? So if it's one of these points along the graph, then it's going to be a solution that works when I plug it back into this equation. So we're going to use that. So if we find 2 or 3 points, we can just connect the dots. And that's what we're going to be doing in this section to plot the graphs. Okay, so turn the page. Let's do a couple examples using that idea. We're going to make a table. And we're going to pick easy values of X. Easy values of X to plug into your table. Make an XY table. So you're going to pick these X values, you're going to plug them into the equation, figure out the Y that goes with them, and then that will give you an XY pair to plot on your graph. Okay? So after you make your table, graph or plot your points, your ordered pairs, your XY pairs, and then connect the dots or draw a line. Draw a line through the dots to see what the graph looks like. So here we go. I'm going to make a table. You get to pick the XY values that make the most sense to you. Might be, let's do -2, 0, and 2. If you want to pick something different, you can. If I plug -2 in here, -2 times -2 is 4, plus 1 is 5. So that gives me the point -2, 5. Let's plug in 0. Well, 0 plus 1 is 1. So I get the point 0, 1. And then if I plug in 2, 2 times -2 is -4, plus 1, -3. Okay, so that's my table. I got my pairs. Let's graph them. -2 up 5. 0 up 1, and then over 2 down 3. I know these graphs are hard to read. And that should make a straight line. If they look like they're all lined up, connect the dots. Now, it's important that you extend your line a little bit past your dots. It should go pretty much off the graph and have an arrowhead at the end. So graphs are not just like little stubby things that end like that. Make them longer with arrows. Longer with arrows. Okay? All right, let's try the next one. X, Y. I'm going to use my same numbers, -2, 0, and 2. And let's plug that in. What's half of -2? Well, that'd be -1 minus 3. Plugging in 0 is usually your easiest one. 0 minus 3. Half of 2 is 1 minus 3. So you're welcome to use a calculator, or this is often something you're just doing in your head. All right, so I have the point -2, -4, 0, -3, 2, -2. So go ahead and plot those. Pause if you need to. Practice plotting them, and then hit play when you're ready to see if they line up with mine. All right, I got my dots on there. This is why you use a pencil, so you don't have that like I do. And then if they look like they're in a nice straight line, connect the dots. Extend, and put an arrow on each end. There we go. All right, let's take a look at these. you notice in this one, y is kind of mixed in. So before I make my table, I want to actually solve for y. So I'm going to do minus 2x on both sides. Y equals 3 minus 2x. I've got y by itself. That's great. And now let's make a table of values. I want you, if you use the same numbers as before, it ends up going off the graph a little bit. So I want you to actually use 0, 2, and 3 and see what you get. Or even 0, 2, 4. You can pick. But pick numbers that will be easy to plug in here. Okay, and then I want you to pause, finish this table, graph them, and see what you get. Hit play when you're ready to check. Okay, that's what I get. You are, again, welcome to choose different values of x that you want to plug in. Get the y that goes with those after you put them into this equation, and then plot the points. Do at least 3 so you can make sure that they do actually make a straight line, and then connect the dots. Okay, here's another one. You'll see that y is kind of mixed in. So I'm going to go ahead and solve it for y, just so it matches my kind of form of what we want a linear equation to look like. So plus 3x on both sides. I'm just solving to get y by itself. Those cancel out, so now I rewrite it and I have 2y equals 1 plus 3x. So I still have to divide by 2, and I have to divide all of this by 2. So what that looks like when I rewrite it, 1 divided by 2 is 1/2. 3 divided by 2 is 3/2. And then that still has the x on it, and everything is positive. All right, let's make our table. Okay, you can choose your own values this time. You're going to be plugging it in here for x, so pick something that's easy to divide by 2. You might go back to your even numbers like -2, 0, 2. But if you want to choose something different, you can. Plug them into here, right? Use your calculator or work it out in your head and figure out what these y values would be. And then plot those on the graph, and hopefully they make a straight line. So pause until you're ready to check this graph when you're done with this one. Okay, check your math here. That's what I got when I finished the table, which gave me these dots, these coordinate points when I graph them, and they make a straight line. Connect them with arrows on both ends. All right, last part of this section is looking at horizontal and vertical lines. So if you remember, horizontal goes this way, vertical goes this way, up and down. So when we have a horizontal line, it means it has a constant y value. A constant y value. So your equations are going to look like this. Y equals a certain value, and it's always that value, a constant number. Y equals 4, y equals -3, y equals any number is going to be ending up looking like a horizontal line. So let's see. If I graph y equals -3, -3, -3, -3, -3, y is always -3, I get this horizontal line. Y equals 4. Oops, that's not -3 at all. Pretend that's a +3. Let's make this a negative since I messed that up. Y equals -4. -4, -4, -4, -4, -4. All of these points where y is -4 would graph like this. Okay. A vertical line is when you have a constant x value. And that looks like these. So x equals something. If x equals 2, here's where x equals 2, and I end up with this vertical line. Or x equals -1, I end up with this vertical line. Okay? So a constant y value gives you a horizontal line. A constant x value gives you a vertical line. And we'll see both of those in this section too. All right.